Hi, today we're going to see another type of trigonometric equation. Let's look at an example. Find all the angles between 0 degree and 360 degree which satisfies the equation sin y equal 4 tangent of y. On this type of equation, we have sin y and tangent of y. None of them are squared, so the only trig identity we can use is tangent of y equal sin y over cosine of y. Okay, here I want to get rid of my fractions, so I'm going to multiply both sides by cosine of y. So on the left side I will get sin y times cosine of y, and on the right side I get 4 sin y. Now I cannot divide by sin y because I might miss solution. So what I'll do instead is I'm going to put everything on the left side of the equation. Now on the left side of the equation I will get sin y cos y minus 4 sin y. At this point, sin y is a common factor on both terms. So what we can do is factor sin y and write the next step as sin y factor of cosine y minus 4 equals 0. Now we have a product of two factors equal to 0, which means that each of the factors can be equal to 0. So we can write sin y equals 0 or cosine y minus 4 equals 0. If we look at the right side, cosine y minus 4 equals 0 is equivalent to cosine y equals 4. Now if you remember, the range of the function cosine is between -1 and +1, meaning that cosine of y can never be equal to 4. So we can say that there is no solution for cosine y equals 4. Now for sin y equals 0, this is a value that you should already know. But if you don't know, you can still do a unit circle. On our unit circle, the y-axis represents the sine value of our angle. We can look at where the sine value or the y-axis is at 0 and then take the associated point on the circle. Here we have an angle at 0 degree, 180 degree. As every time, if you have 0 degree, also remember to write 360 as 0 degree and 360 are basically the same thing. So this is the solution to this exercise. The three angles we're looking for are 0, 180 and 360. Let's look at a second example. Find all the angles between 0 degree and 360 degree which satisfies the equation 2 cos square of y minus 1 equals sine of y. This time we have cosine square of y. So we're going to use the trig identity with the cosine square. So if you remember, we can write cosine square of y as 1 minus sine square. This comes from the identity sine square of y plus cosine square of y equals 1. So we can rewrite the equation as 2 factors of 1 minus sine square of y minus 1 equals sine of y. Now we can distribute the 2 and simplify the left side. So we'll get 2 minus 2 sine square of y minus 1 equals sine y. Now we can simplify and reorder the terms. Now you might notice that this equation looks like a quadratic equation. In order to make it simpler to solve, we can substitute x equals sine of y, and this will make the equation be 2x squared plus x minus 1 equals 0. At this point, we can either factorize or use the quadratic formula. We find two solutions, x equal 1 over 2 or x equal -1. Remember that we are not solving for x, but we are solving for y in this case. So we need to substitute back x equals sine y, which will give us sine of y equal 1 over 2 or sine of y equal -1. For sine y equal -1, this is a value that you should know, but if you forgot, on the unit circle, we are at the bottom of the unit circle. At the bottom of the unit circle, this is the angle y equal 270 degrees. Same thing, sine y equal 1 over 2. You should know the value of alpha in that case. Alpha is 30 degrees. Once we have alpha, we can place it in quadrant 1 and 2 because sine is positive in quadrant 1 and 2. If we put alpha equal 30 degrees in quadrant 1 and 2, we get the angle y equal 30 degrees and y equal 150 degrees. Now we can combine all the angles that we found, and we found the final solution, which is y equal 30 degrees, 150 degrees, and 270 degrees. This is the final solution for this type of question.